we have some of the cleverest, best people on the planet here talking about CSI. They've built this stuff from scratch. They work with it every single day. So I'm here as a moderator to ask the first few questions, but then it's like all of you guys need to start asking questions. Otherwise, it's going to be really, really, really boring. So first question, what is CSI? Explain CSI to the uninitiated.
That's a good question. How many of you know what CSI is? How many of you have built a CSI driver? Wow, that's, yeah, we're in the right room. So CSI is, I think for the folks that were attending earlier today, there was a good history given. It's an evolution of where Kubernetes started. Somebody mentioned what is the difference between Docker volumes and Flex and CSI, and it's kind of a progression on everything. So Docker volumes was an attempt to make storage available to a single container, but it's very much at that single node level, a single machine. You have a container running, you're figuring out how to make storage available to that container. When you take a step back from that into a distributed system where you have hundreds of machines, you end up with new challenges of actually making a volume available to a container. Now a container may be moved from one machine to another machine to another machine. You have this challenge of the storage needs to actually be able to move around from one node to another node, and you have to have some way to be able to express that to the storage control plane. And so that's what the initial Kubernetes storage API did, was that it allowed you to say, I want storage, and regardless of where it ends up on the cluster, make sure just automatically make it available to me. And the interface that we wrote at that time was completely in tree. It was part of the Go binaries, part of the Go binaries that we shipped with Kubernetes, where they would do attach, mount, and then eventually provision the volume dynamically. But that was not extendable or scalable because for multiple reasons. Like if you're building these third-party plugins into the core of Kubernetes, that means that if there's a bug in one of these drivers, it will crash Kubernetes. And this is something that we've seen is you'll have Kubernetes, you'll have a problem with an entry volume plugin that you haven't even activated, but a user tried to use it and it'll blow up your kubelet. That's insane. You're giving these entry volume plugins permissions, security permissions to the same security permissions that you're giving to your kubelet and your other key Kubernetes components. That doesn't make sense. But during that initial development of Kubernetes, it allowed us to move very, very quickly because we could keep iterating on that API and figure out what it should look like. And every time we released, there was a set of drivers that you knew were going to work with every single Kubernetes release. But once it got to a point where we had something like 10 or 15 entry drivers, for the reasons that I mentioned earlier, in addition to the fact that you can't actually test these things, right? In the Kubernetes CI/CD, how do you test a fiber channel driver? We're not doing it, and we're just hoping that the community actually notices bugs and reports them, which is not a very good place to be. So for those reasons, we decided, okay, we need to actually have a real pluggable driver system. And the first attempt at that was Flex Volumes, which was led by Chakri back there. And it was a exec-based system where you have the basic operations that Kubernetes has, mount, attach. It was just mount and attach, honestly. And in order to fulfill those, there was a binary, an executable that you would deploy on every single node. And anytime for that driver, Kubernetes needed to do a mount or attach, it would call out to that binary, and the binary would fulfill that request and return some response. So it was very, very simple, but there was a lot of challenges around it. And the challenges were mostly around deployment. How do you, like if you're actually manually copying files to nodes, that is a very anti-Kubernetes pattern. What happens in the cloud where if your node dies and it comes back up, who's responsible for ensuring those files exist? And what if, especially in cloud environments, you might not have access to the master control plane. So how do you actually do an attach that depends on the master if you can't copy files to the master? So those are some of the challenges with Flex. It solved a major challenge that we were having in the community, but it didn't go far enough. And then we started thinking about what the next steps were. And as we started to figure out what the next steps were, we kind of started hearing rumblings about this is a problem that a lot of orchestrators were facing. And at the time, it wasn't clear who the winner of the orchestration war was going to be. You had Kubernetes, of course, but also Mesosphere. You had Docker Swarm at the time, and then Cloud Foundry was doing their own thing at that time. And everybody kind of was running into the same set of challenges of like, I need to make storage available in my orchestration system, and my orchestrator needs to have some way to be able to talk to it. So instead of each of us trying to come up with our own system and making storage vendors write 5 different drivers, we decided maybe it would be beneficial if we all collaborated, orchestrators and storage vendors, on an interface that would work for all of us. So we converted our Flex 2.0 conversations and energy into focusing on CSI and coming up with a standard that would allow us to build out volume plugins in an extensible way. So the initial conversation started about 2 years ago, and it was led by folks in the Kubernetes community, Mesos, Cloud Foundry, Docker, and a handful of storage vendors. And the initial version of the spec came out almost a little over a year ago, 0.1. And that's kind of where it was born.
Brilliant. So we know that CSI gives you an API between a container orchestrator and a storage system. What's the difference between CSI and the Kubernetes CSI?
Go ahead. So Kubernetes, or the CSI spec, is just that, it's a spec. Right, and so there's no state that's maintained in the spec itself. So it's on Kubernetes, or the container orchestration piece, to maintain the state of the interface. So if something's mounted or unmounted, Kubernetes needs to actually manage that. There's nothing in the spec about how it maintains that state. It's all up to the orchestration platform, and that's really the difference. It's just a spec. CSI is just a spec.
Yeah, the way to think about it is like a networking protocol. There is the specification that defines what that protocol looks like, and then there's an implementation that implements it. So CSI is just a specification. It just says this is how, it's a contract between how we talk to each other. And then Kubernetes actually needs to go and implement that API on the Kubernetes side to say, if there is a driver out there that exposes a CSI interface, I will be able to talk to it. And then on the storage vendor side, they can write a CSI driver that also understands CSI. So it's a language, and then it's an implementation.
And I wanted to add that you had mentioned that CSI started about a year ago at 0.1, and I wanted to point out that now we are at 1.0.
1.0, yeah.
Starting with 1.13.
It's a huge milestone.
Yeah. 1.01. Yeah, 1.01.
So that's a brilliant segue, because my next question is, when did CSI become part of Kubernetes?
Sorry.
And what's new about 1.0?
Yeah. I guess.
I think we should talk about the snapshots a little bit. What's new in 1.0? Yeah.
Yeah. Okay. Yeah. So we added snapshot support. Actually, that's actually added in 0.3. But now it's GA, so it's part of the 1.0 release. So that's really cool. And also we also have the topology support that's alpha right now, and also the dual block volume support that's also added in 1.0, right? And then the kubelet plugin watcher that was coming earlier, right? That was actually in 0.3. Yeah, that was earlier.
One of the key things that we wanted to do when we first started the project is that we wanted to make sure that the spec was able to do what it said we could do. So one of the things that we would try to do a lot working together is we wanted to make sure that both we had very early implementations of Kubernetes into version 0.1 and 0.2 and 0.3 of CSI, and very early versions of the driver. So we try to do this as fast as possible so we can make sure that the CSI spec was, could actually accomplish what we wanted to do. So this journey that we have taken from the beginning to now has been, quite a challenge, but it has been quite productive. So.
Yeah, I'd like to underscore that is, I think the thing that you realize when you build out an interface is that it's very, very difficult to get it right and make everybody happy. and we knew that we weren't going to get it right the first time. And so the reason that a year ago we didn't call it 1.0 was that we realized you can't just develop an interface in isolation and say, okay, this is it, this is the standard. We wanted to actually have implementations built out both on the orchestrator side as well as on the storage vendor side, and see, like, in actual implementation, does this thing work, and allow us the ability to revise it. So within the 0.x releases, we made multiple breaking changes to get to 1.0. And 1.0 is not the terminal, like, finished product. The idea with 1.0 is that this is the basis that we're going to build everything else on top of, but it's a stable base. We're not going to break vendors who will implement storage CSI 1.0. Going forward, we're going to add functionality, of course, as we move forward, but the idea is that now it's a stable base, we know it works, and anything that's going to be added is going to be additive, not breaking.
So as a storage vendor, I can only applaud the pragmatism with the CSI spec and how it's developed over the last year. And it's made it very easy, I think, for a number of drivers to proliferate. I think there's over 15 now.
Yeah.
So with all of this functionality, and now that we have 1.0, what can people in the audience do with CSI?
So if you're an end user, CSI basically makes more storage systems available to you more quickly than we were able to do in the past. In the past, the only way you could add additional storage systems was hope that your storage vendor was going to put up with the Kubernetes release process and go and try to commit code there and wait for a Kubernetes release and then revise bugs. Now you can just go to your storage vendor and say, do you have a CSI driver that I can use with my Kubernetes cluster? And they can work on a completely independent schedule of the Kubernetes releases. And beyond that, all the new functionality that we're going to be adding to the Kubernetes storage layer is going to be added to CSI first and probably only in CSI. So for example, for Flex, we're going to freeze development now. We're going to maintain it and continue to support it, but like new functionality like snapshots and cloning and these other things that we're looking at are going to be CSI first and probably only in CSI.
One of the things that actually that does too, kind of the opposite side, is that if the vendor does say, I do have a driver, but it's on this version, it doesn't force the user, to move to that Kubernetes version if you don't want to. It actually allows that flexibility of taking that driver and plug it into your own stable Kubernetes version.
Okay, so we've got into maybe a good understanding of CSI so far. Are there any questions from the audience? Come on, make this interesting.
So in the CSI spec, it refers to the CO, and the CO, as far as I've seen, is always like Kubernetes. Are people actually using CSI outside of it? Like, for example, Docker, replacing the Docker volume driver with a CSI driver. Is that a thing anybody's doing?
So the big other implementation is Mesosphere with Mesos. But Docker, Cloud Foundry, Mesos have all been very, very closely involved in CSI and are maintainers on CSI. In terms of actual implementation, both Mesos and Cloud Foundry have an experimental implementation of CSI, and they plan to develop that out because they want to move to GA soon. Docker is interesting because CSI is an orchestration layer interface. So for the Docker container runtime, it doesn't make sense to use CSI. So they're going to continue to use volumes. For the Docker Swarm product, which is their cluster orchestration system, I think Deep is over here, and he might be able to actually answer that better for you. But my understanding is that they're actually going to lean on Kubernetes. Kubernetes will be part of Docker Swarm, and they'll use the Kubernetes implementation of CSI. But talk to the Docker folks to get a better understanding of that.
I'm just going to add a little bit on that. Even though the client, speaking specifically to the spec, even though we think of the caller as the CO, we actually have many types of callers to CSI drivers. We have provisioners, we have attachers, we have many things that do that. We have testing programs. What I'm trying to say is that the CSI spec, even though it mentions the caller as a CO, it doesn't preclude that it can only be a CO. It can be many things. Something we maybe haven't thought about yet, but it allows any client that has that contract to be able to satisfy it.
I also wanted to mention that OpenStack is using CSI to port some of their data services over to Kubernetes.
And that's not a CO.
Thank you.
Not a
Yeah.
CO.
So just two questions, actually, if I may abuse this. I'm interested in cryo and to see if there's any, if the support level within the two runtimes are at the same level right now, and if there's any information on RDMA support with CSI and Kubernetes.
I have no idea what RDMA is. Does anyone know?
I don't think that again, I've worked with RDMA very little, but I think that is a property of the storage system. The request coming from CSI is quite simple. It's just saying I need this here, attach it, and then let you figure it out. So I'm assuming that the caller created the correct storage classes and definitions and the correct setup for the storage system to be able to attach it. And then it is up to the CSI driver implementation for that RDMA system to be able to do that. The CRIO, I don't know how to answer.
So Kubernetes or CSI doesn't operate at the container runtime level. The assumption is that it interacts with the storage system to get a mount point on the host machine, and then takes that mount point and passes that along to Kubernetes, which passes it along to the container runtime. So CSI's contract kind of ends at making that mount point available, and then it's a contract between Kubernetes and CRI to figure out how to actually expose that mount point into the container. So if RDMA is a property of the container runtime, then it's outside of the scope of what CSI is doing.
And again, I just want to step back a little bit and make sure we understand that it is the host that does the attachments, not the containers, right? So when we do attachment of storage, it is the kernel in the host that's making the attachment into the system, and then we bind mount that into the container. Okay.
And that's the way it is today, but we are investigating possibly doing it inside the container for security reasons. So there's Kata containers and gvisor, and one of the big gaps that they have in terms of security right now is the fact that the actual mounts are happening on the underlying node host, that any bugs there could basically expose the host file system to the container. And so we are looking into potentially, at least for these secure containers, possibly running CSI inside of the container runtime as well.
You say that someone can just write a driver to support that, right? So it's not, there's nothing stop you from writing a driver, but it's not part of the CSI spec.
And if you guys are interested in the security side of this, Michelle Wu and Jan Sefranek are giving a talk called How, I think it's How Symlinks Pawned Kubernetes. And it is a very interesting talk about how there was a Kubernetes feature that allowed containers to break out and get access to the host file system. So this is a very real issue.
We recently hit what I would call feature in Kubernetes that if you run a container not as root and mount a volume, then it will change on every single file in that volume.
Oof.
So if you run a volume with like 200,000 files, it takes half an hour to start it.
Yeah.
Do you have, so that was flex volume, not CSI. So do you have plans to test against bigger data sets in CSI? Or from side of Kubernetes, not from side of like implementations? Thank you.
Look at Brad for this
Yes,
one.
we do.
Please do.
Yeah, that's a known issue, and hopefully we'll have tests that we can run against plugins to validate that that doesn't happening?
I think the fundamental challenge there is the fact that we're expecting the storage system to apply permissions at a per file or per directory granularity, and that is a linear problem that scales with the size of your data. And we need to potentially think of other ways to be able to solve that, and whether, yeah, I'll leave it at that.
Any other questions?
Do you know of any exotic uses of CSI outside of just object storage and file, block mounts? Maybe somebody's using it like as a MySQL CSI storage engine, and every table is a block storage, and only the node with all of the mount points can execute the query.
Not like that, but again, I mean, the CSI spec is quite specific on, volume creation, snapshots, and things like that. But I wouldn't say that I've never seen that type of use case. But again, going back to what I said before, is that you don't have to be a CO to consume a CSI driver. You could have your own method of requesting and accessing storage. So, which we haven't heard yet, but I'm sure will happen. So.
And the cool thing about CSI now is that you don't actually have to advertise what you're doing, so we don't know what people are actually doing. It's
yes,
private.
Right. They won't tell us.
So one of the things that people often ask is, now that we have CSI, what happens to all of the entry plugins and the existing Flex driver plugins? What's the transition, and what should somebody do if they're already using those plugins?
Yeah, that's a good question. If you have a new CSI driver that's created and your customers are going to depend on that, the answer is pretty straightforward. You have the customer deploy your CSI driver and begin to use it. If you have a customer that is depending on an entry volume plugin, things get a little bit more murky. We're going to continue to support entry volume plugins, but in the SIG, we're developing a plan at the moment to try to automatically migrate over the current entry volume plugins that we have to CSI. So at least we're going to start with the cloud provider ones, GCPD, AWS, and a couple others, where we want to remove the code from entry and proxy it out to a CSI driver, and as part of the Kubernetes deployment, the CSI driver would be installed. So plan of record for that implementation right now is we want to get to an alpha by Q1 of this year, a beta by Q2, and then GA by Q3, and then hopefully 2 releases after that remove the entry code. That said, it's very, very early in that process, and I was talking to Brad about this outside, and it's going to be a very, very large effort where the success metric is that nobody notices. Like, if anybody notices, we screwed up. And it's an immense amount of work to get to that point. And so we're kind of weighing the trade-offs between, given the amount of work it is, do we actually want to do this or not? If we end up not doing it, what it means is that these storage vendors that are kind of across a CSI driver and an entry driver now are straddling 2 code bases, and it's a pretty fragmented experience for end users because you have an older entry driver that doesn't have new functionality. So my feeling right now is that we want to kind of reduce the pain for users, and we're planning to invest in this migration, but of course nothing is final or locked down yet.
It's been like a year, right? We've been working on the migration.
Yeah, it's first get CSI out, and now that we have CSI out, the next thing is, okay, what's the next step? What do we do with the things that we already have entry? And that's what we're figuring out.
Any other questions from the audience?
So if you look on the CSI roadmap, how much is it influenced by the end users as opposed to by vendors?
That is a very good question. So if you look at, so the interesting thing about CSI is that it's not yet a CNCF project, and it's not part of Kubernetes. It's actually a external organization, essentially, and if you look at the approvers on CSI, specifically the governance documents of CSI do not allow storage vendors to be approvers on CSI. They only allow cluster orchestrators to be representatives as approvers. And the reason for that was very deliberate in that while CSI absolutely must be driven by storage vendors and they must have influence in it, they must contribute to it, ultimately the goal for CSI is to be a interface that empowers end users and gives them easy way to use storage. And so therefore the proxy for that is that the cluster orchestrators basically are the proxy for the end user, and they are the ones that are empowered to kind of approve the changes in CSI. So the typical pattern would be that somebody, it could be a storage vendor, it could be anybody, will contribute to propose something new to the CSI, and then it's an open community. Everybody's welcome to debate. And
debate we do.
And we very much do. And then hopefully we all come to consensus as a community, and then it gets approved. Yeah, does that answer your question?
Yeah, and just to add to that, a lot of the storage vendors come in with use cases coming from users. So we represent them.
Yeah.
This is quite kind of sometimes very low level, unless the users really like APIs and stuff and arguing, which is kind of weird. But if they like it, they can join. One of the things too is that the CSI spec right now is quite young in a way, I want to say, because it only does creation and volume management. There's nothing very exotic about it. So today as 1.0, we have a very clean, simple API.
So we talked a little bit about migrations from the current drivers, and we talked about what's in CSI and the 1.0 release. What's on the roadmap? What's in the future of CSI?
Good question. So
somebody other than Saad answer
yeah,
this.
I was going to hand it over to Xing, who's actually been working on snapshots.
Yeah, so we have just added the basic support for volume snapshot, and the next thing we are looking at is to add an execution hook for volume snapshot to quiesce and freeze before taking the snapshot, and also unquiesce, unfreeze after that. We're actually thinking about maybe we could even add this freeze function into the CSI spec itself, but that's something that we need to discuss as a community. And the other thing is there's now the topology support for volume that's in alpha state. We are also looking at adding the topology support for snapshot. And then there's another thing called a readiness gate, but I think that's not really the CSI specific. That's really Kubernetes thing to check if a persistent volume claim really has the data populated in it. So that's relevant to create a volume from snapshot and clone. That's something that's actually clone actually was just added in the CSI spec, but it's not implemented in Kubernetes yet. So that's something that is work in progress. And
maybe Vlad can talk about.
So the group snapshot, yeah, that's also something that we are looking at. But I think we had a discussion with the SIG architecture last time. There were some concerns saying that it's too complicated. So we are still looking. We're still discussing. So right now we are focusing on the execution hook part. Yeah.
Another thing we've been trying to bring into CSI is inline volume. So if you don't know what it is, basically existing storage drivers support what we call inline embedding of volume into a pod spec. Today, CSI doesn't support that. And for the last couple quarters, we've been churning, trying to figure out the best way to bring that online. Hopefully, 1.14 will be the lucky release that gets it. So that's another thing that's coming into CSI. That's the only thing I can think of.
Kubernetes CSI.
Kubernetes CSI, not CSI itself. This is a good point. CSI being a spec that everybody agrees on, but the implementers of CSI can implement CSI however they see fit. And that's exactly what's been happening with Kubernetes. There are places where we've had to kind of extend how CSI works. For instance, the CSI driver API object and the CSI driver node info object. These are not necessarily part of CSI, but there are things that we had to do to extend how CSI works specifically for the Kubernetes implementation.
So I think just to summarize that real quick, a lot of the work now is not going to be in the actual spec itself. It'll be on the Kubernetes implementation of the spec. The initial version of Kubernetes CSI that we had was very narrowly scoped to focus on remote persistent storage. And there are a number of other use cases that we want to extend to. So like with inline volumes, that's a requirement for local ephemeral volumes. So if you're used to things like secret volumes or config map volumes or downward API volumes, empty DIRs, those are volume types that we want to be able to allow end users to be able to build out. And so we're going to build functionality that'll enable things like that.
Brilliant. So I think we're nearly up for time. So one last question. If somebody wants to get involved, oh, we've got another. Okay, one sec.
Also answer that question. That's
Yeah.
the most important question.
If somebody wants to get involved, what do they do? What are the mailing lists, the meetings?
In which project?
Yeah. How? Yeah, because you can be involved.
Yeah, you go ahead. Yours.
No, what I was going to say is you can be involved as an implementer of CSI, or be involved as somebody who's working inside Kubernetes to make CSI works. So I'm guessing we're talking about as a Kubernetes implementer. So we have meetings 3 times a week. So if you're up for giving up half of your hours every 3 times a week, you're welcome to join us.
So let's say there's 2 major communities. One is
Right.
the CSI community, which is focused purely on the spec and is beyond just Kubernetes. We have folks from Mesos and all these other communities that are part of that. That meets once a week, 9 a.m. on Wednesdays. And that's focused purely on changes to the CSI spec. So if you're interested in that, take a look at that. If you're interested in the Kubernetes implementation of CSI, then there's 2 venues for you. One is the Kubernetes storage SIG. We meet every 2 weeks, 9 a.m. on Thursday. And the Kubernetes storage special interest group is mostly tracking what are the changes going into the next release kind of thing. If you're very much interested specifically in helping implement the Kubernetes CSI implementation group, this group meets 3 times a week, and you are absolutely welcome to join that as well and help out. There's a lot of work left to be done, and it's a very small group, as you can see, who's been doing a lot of the work. And
with documentation.
Yes, we would love your help with documentation, and there's a lot of work left to be done.
Tests,
So I love all the people that are showing up here. So if we could
Yeah.
get more help from at least some of you, that would be wonderful.
And if you're a user, we also have a Slack channel called WG-CSI. Actually, we have a lot of communication there. We take a lot of questions, and we participate in solutions and things like that. We also have an emailing list, but I think the emailing list is more for developers. But the best, I think if you're a user, the best way to get to us, talk to us, questions, things like that, is through WG-CSI on Kubernetes Slack.
How quick is that question? We're already 5 minutes.
Yeah. Super fast, yes. Super fast. So I just heard about the execution hooks for the volume snapshotting. So is that something to do with app-aware snapshots?
Yes.
Yeah.
We can talk afterwards.
That is. Actually, there is a meetup on Wednesday. We will be talking more about that in detail.
Cool. I think we're done. So good job, everyone.
Thank you.
And a quick round of applause.